This is a quick review on how to assemble objects, 3D parts that you've made in Autodesk Inventor. I'm going to go over this somewhat quick. This is more intended as again, a review for people that have already done this. So if you want to fully understand this, I have some various other lessons that kind of go more in depth about this kind of stuff. But I want to walk you through. The goal here is we're going to walk you through assembling two pieces together, and this is more focused on the assembly mirror project, only looking at two types of constraints, mate and flush. So let's say you have all your parts 3D modeled. This is Autodesk Inventor. We're going to create a new file, and we're going to do an assembly file. So if you look at, here's the assembly section. Notice for part file just shows like, hey, here's a cube, and then assembly is, let's put some cubes together. And then eventually, once you're done with the assembly, you'll do a technical drawing, which is, if you look, that's like the pictures of them. Anyway, so you'd click standard.iam. That's what we're going to use for assembling, making an assembly. You'll click create. I've already created one, so I'm just going to go cancel for now. What you need to do is you need to place your parts in. I recommend, it kind of depends on how many parts you have. If you want to place in all your parts at one time, whatever, that's fine. So I'm just going to place in 2 parts for now. So I clicked place in the upper left corner there. Now I need to find where my files are, and it depends on where you save them. Saving in this program is incredibly important. I've mentioned that many times. You should be saving in your OneDrive, or if you have an H drive, saving in your H drive here at the school. So hopefully you remember where you save them. If you save them in like my documents kind of thing, you might run into some problems. So I saved in the H drive there. I'm going to scroll down. I got to find my files. So here are my part files. I'm going to do, let's do the top, and then I'm going to do the left right away as well. So I'm holding control, and I can click multiple things at a time when I hold control. And I'm going to click open, and now the computer is going to let me place them in. So I know we're zoomed in really far here. There we go. Using I don't have I'm just using my trackpad, so I don't have a good mouse here. I click those in. So I click them in. They're in my assembly, and notice that I can click in more if I really wanted to. So if I had more of these parts to click in, I could just click some more. I don't. I just need 2 or 1 of each. So I press escape. Now here are my parts. I can click them and drag them and move them around. First thing to do, in the browser, remember the browser tells us our history and things that we've done. We need to click these pluses. Always have these pluses open for each part. If you notice, this is the part, left side, it highlights. I click this here, that's the top, it highlights. You're going to start seeing the constraints on these things. Here's something else I need you to do. We might not have done this before, but I need you to do this now because this will help keep your thing from getting crooked. We need to assemble or constrain at least one of the pieces to the axes here. So we got our X, Y, Z. We're going to constrain this to those axes. So for example, I have the X, Z plane, and I'm going to mate. So I click constrain. Here's mate. I'm going to mate this side to that axis. I click apply. Okay. And then I have the top. What would that be? XZ. So I click XZ, and I'm going to constrain. I'm going to mate the top of this piece to the XZ. You gotta zoom in. Come on, mouse. It's not letting me zoom in. You gotta be precise. Notice I'm being very precise. I'm trying not to click the edge. I'm trying to click the top surface. I gotta zoom in here. There we go. I'm gonna click mate on the top. Boom. I click apply. Now I can kind of see what I got here. The reason why I did that is that's going to help me from getting crooked views later on. So this piece I'm calling kind of like my base. This piece is like locked in. It's locked in on these 2 axes here. And you should only really have to do it to 2. And now I'm going to change my view cube to say what I want it to say. This is the front view. So I'm going to set current view as front, because this is the front view of the left side here. Now this piece, to help me kind of understand it better, I'm going to click this free rotate. I left click free rotate, I click the piece, and now I can drag with my mouse and kind of move it around. You don't have to do this, but it can just kind of help our brains understand where the pieces are going to go. So it can help with that. This piece is going to go on top here. With assembling, essentially what you're doing in this 3D world, you're telling the relationship. What's the relationship between those two pieces? So in this case, I'm essentially telling the pieces to go kind of like this. I don't have the right joint at the top, but I'm kind of telling the pieces to go like this. In the bottom left corner, you see we have 3 axes. So I have to do, in general, most of the time you're constraining, you have to do 3 constraints, 1 in each axis to keep the thing from moving in the other axes. So like let's say, so right now Y is the vertical axis. Let's say I constrain it in the X, I constrain it in the Z, but I don't constrain it in the Y. That means I'll be able to move it in the Y. So we have a rhyme. Our rhyme is XYZ, constrain all 3, because you have to do 3 constraints in general to constrain the piece. I'm going to show you what that looks like. First, I need to explain to you the difference between mate and flush. So if you look here, we open those pluses. Now we can see that we did those 2 mates, where we mated this thing to the axes. So if you see my 2 boards here, if I want these 2 like this surface here and this surface here, if I want those surfaces to touch, I want you to imagine we drew eyeballs, and I actually have eyeballs drawn on this one here. So imagine the eyeballs on this piece, this surface, and the eyeballs on this surface. So these 2 surfaces, the eyeballs, they're looking towards each other. They're looking exactly at each other. They're like staring at each other. So when the eyeballs are looking towards each other, that would be a mate. When the eyeballs are looking, if you kind of think about it with your fingers too, if you do it with your fingers, right now the eyes are not looking at each other. They're looking at the camera. So if I turn my hands, right now the eyes are looking at each other. So that would be considered a mate. And then flush is different. So if I mated, we'll take a look at how this looks on the computer in a second here. But I mate, boom, boom, it'll go like that in the computer. I've only done 1 constraint so far. I have to do 2 more. Otherwise, this stuff, like right now I can't pull them apart, let's say, in the computer program, but I can slide them this way, and I can slide them this way, because I didn't constrain those edges. Now if you look at these 2 edges, think about if there's eyeballs drawn on there, which again so I have some eyeballs on there. These eyeballs, they're not looking at each other. They're both looking at the camera. Or we could say they're both looking at the same wall. When the eyeballs are looking at the same wall, we would call that a flush. Excuse me. So let's try and see what this looks like on the computer. This surface and this surface, those are both facing the front. So imagine there's eyeballs on here. Answer in your head right now. Eyeballs on here, eyeballs on here. They're both facing the same wall. So would that be a mate or a flush? If you said flush, you're correct. So I click flush. Now I have to tell the computer which pieces I want to flush, or which surfaces. I click here, I click here, and then I click apply. Boom. Those things are now flush. Think in your head right now, how many more constraints do I have to do? I've done 1 so far, so hopefully you answered that I have to do 2 constraints yet. The constraint that I did looks like it's the z-axis. I'm sorry, I messed up there. That's the x. Right now in this instance, I stopped the x-axis. Like these 2 surfaces are in line, I can't move them this way from each other. So I did the x-axis. You can see it there. The arrow points to the surface that I did. Now, I got this surface and this surface. Try and zoom in. Come on, mouse. There we go. This surface and this surface. Think if there's eyeballs drawn on them, where are they looking? This surface and this surface. Are they going to be looking at each other, which is the mate, or are those eyeballs going to be looking at the same wall, which is a flush? So if you said flush, you'd be correct. I'm going to flush this surface and this surface. I go to constrain, I click flush, I click this surface and this surface. Notice you can see the arrows. I should reverse my hands here. The arrows are both pointing like at the same wall. So that's one way I know it's a flush. So I click apply. I'm almost done. I have 2 constraints. I have one more constraint to do. Notice I can pull this up. That's the only thing I did not constrain yet. This is locked in. I can't like slide it left and right. This I can't slide left and right. I can only slide it up and down. So that means I need to stop the up and down movement. So now think about this. This surface right here, which we can see, and the underside of this lip, which we can't see from this view right now. What type of constraint would that be and why? If you said mate, that would be correct, because think of the eyeballs. There's eyeballs on here. There's eyeballs on the underside of this. Those eyeballs, in this case, they're looking at each other. So that means I need to mate that. So I'm going to try and zoom in a little bit here. Very important when you're mating. This is a very common mistake. People will click the edge like this. That's a super common mistake. You don't want to do that. That's going to mess things up. Like, there's some instances we'll do that, but if you're putting stuff together like a box kind of thing, usually you never ever want to click this edge. That's going to mess stuff up, so don't do that. Click the surface. Notice the arrow, my arrow is pointing up. It's pointing up at the piece I'm going to mate it to. Now, I need to move my camera. And this is, notice the arrows. The arrows are now pointing towards each other. When they're pointing towards each other, again, that's a mate. So I click there, it brought it down. I click apply. But I want to show you one more thing. This is something you will probably run into at some point. If I want to offset those, let's say for some reason that top piece is supposed to be slightly above or hover, then I can type in, let's just say 1 inch. Notice I said 1 inch, it brought it up. So you can still lock stuff in, like we need stuff locked in. The test to make sure if you did this right is each piece you're going to click and wiggle it. If it falls apart, then you know that you missed a constraint somewhere. So even if, like, so for example, in this project, the plexiglass is something you might have to offset a little bit so it's centered. So you might have to do an offset, mate, or flush. Anyway, I don't need to offset this right now. It should be at 0. So I'm going to click apply. And then here is my stuff. I click the piece, I try to drag it off, it doesn't come off. I click the piece, try and drag it off, it doesn't come off. And now notice if I go to my front view, this is starting to look like my actual project here. This is the front view of both things, so that's correct. That's why we locked in this yellow piece initially. I want to make sure I'm regularly saving, so I of course would do File, Save As, and I'd be saving where all the rest of my parts are. So whether you're saving in your OneDrive or H drive, those are really the only 2 options as of me recording this right now. Those are kind of the only 2 options that work properly. OneDrive or H drive, Save As, make sure you name it what it is. And then now I'd start placing in my other parts. So let's say I'm going to place it in the bottom. Okay, so then I open that up, I place it in, press Escape, and then I can start moving this around and placing that where I want. If you were typing in the dimensions that were rounded up, your thing is probably not going to fit together right. You're going to have to go back to each part and change it. So for these slots are an 1/8 inch thick. On the technical drawing only shows 2 decimal points. So it rounds up. So 1/8 has decimal points 0.125. On the technical drawing it says 0.13, which we discussed this in class. Like, you have to use the proper numbers. It's not a big deal. You just go back to your part and fix those numbers. So if you typed in 0.13 for the thickness, go back to your proper sketch, change that to 0.125. And then also, what's going to really mess stuff up is for these cuts, like the depth of these cuts, if you wrote 0.38, that is not correct, and that's going to mess up. When you're doing constraints, you're going to get an error. I'm going to show you what an error looks like, for example. If I try to constrain, I'm going to try to mate this side to this side. I'm going to get an error. So if you're doing something that the computer's saying you can't do, you're going to get this error. So if you're trying to constrain something together and some of your dimensions are off, you're going to get an error. So if you did 0.38 for your thickness or the depth, that's going to cause an issue. 0.38 is rounded up from 0.375. 0.375 is the same as 3/8, which is half of 3/4. Again, so all this stuff that I'm saying right now, if you're having issues or mess it up or whatever, that's why we're doing this as a review type project and doing this type of thing early on, so you can get used to these dimensions, these numbers. These are all just common numbers you're going to see a lot when you're woodworking. So whenever you see 0.38, you're thinking 0.375 and 3/8. Anyway, do what you can. My expectation is that you try and attempt to use this information to help you and help each other. And good luck.